Let's solve some questions from the chapter Square and Square Roots. So let's check the first question. What is the square of the number 15? So how do we find the square of a number 15? We multiply 15 by itself, right? So 5 5s are 25. We have 2 balance. 5 ones are 5 plus 2 is 7. 1 5s are 5. 1 ones are 1. We have 5. 7 plus 5 is 12, right? And we have a 2 here. So the answer is 225 for the question. Now, which of the following is a perfect square? So how do we know when a number is a perfect square? There are different types of methods, but let's see. 97. Let's do the prime factorization here. So is 2 divisible in 97? No, it's not. What else is divisible in 97? Is 3 divisible in 97? 9 plus 7 is what? 16. No, 3 is also not divisible in 97. So what else is divisible in 97? 5? No. 7? No. So let's keep it there. 121. So this would be, we could put it as 97 and 1 here. 121. So what about 2 is not divisible, 3 is not divisible, 5 is not divisible, 7, let's see 7, 1 7 is 7, 551, no. What about 11 though? 11 into 11, what is 11 into 11? 1 ones are 1, 1, 1, 1, 2, 1, 121. Now there's an easy method to do this. So now we get 2 times 11, that is 11, 11 here again. So 1, we got a pair of 11 into 11. So we found the answer, which is 121. Now we could actually see what happens if we do for 136. It's divisible by 2. So 7 2s are 14. So 6 2s are 12. 1 6 8 2s are 16. Again by 2. 3 2s are 6. 4 2s are 8. 2 again. 1 2s are 2. 7 2s are 14. Now 17 is a prime number. So 17 here it goes. Now this is a pair, but what about this? It's not a pair, so it's not a perfect square. Again, let's go for 155. 155, is it divisible in 2? No, it's not divisible in 2. Is it divisible in 3? 6 plus 5 is 11. It's not divisible in 3. Is it divisible in 5? Let's check. The last digit is 5, so yeah, it is divisible in 5. So 3 5s are 15 and 1 5s are 5. So 31, again, we're at a dead end. So here again we didn't get a pair. This is the only number where we got a pair of numbers which is multiplied by each other to give the answer. So basically 121 is a perfect square. Moving on to the next question. What is the square root of 1764? So to find the square root we have two different methods. One is the long division method and the next one is the prime factorization method. Now let's use the prime factorization method, which is the easier one. So we could do it in both ways. So let's first do the prime factorization method. 1764. Now prime factorizing, it's divisible in 2. So 9 8 2s are 16, 1 6 8 2s are 16, 2 again divided by 2, 4 4 1. Now, is it divisible in 2? No. Is it divisible in 3? Yes, it is, because 4 plus 4 is 8 and 8 plus 1 is 9. And 9 is a number which is divisible in 3. So, let's divide this by 3. We get 1 times 3 is 3. 1 balance 14. 4 3s are 12. 2 balance 21. 7 3s are 21. Now, 147. Is it divisible in 2? It's not. Is it divisible in 3? Let's check. 7 plus 1 is 8 and 8 plus 4 is 12. So 12 is a number which is divisible in 3. So let's again divide it by 3. 4 3s are 12, 27, 9 3s are 27. Now, which is the number which is divisible in 49? We know that 7. Again we get 7 and 7 times 7. 1 times 7 is 7. So we get a pair of numbers. We are grouping it by pair. We got one pair of 2, one pair of 3 and one pair of 7. So we multiply all this. 2 into 3 into 7. What is this? 6, 7. This is 6 into 7 is 42. We got the answer as 42. Now let's do the long division method. 1764. Okay. Now we are pairing it from here. These are the two pairs. So which is the closest square which is near to 17? It's what is the closest square? It's 4 square. 4 into 4 is 16. So we put 4 here and we put 4 here too. Now here we'll add 4. 4 4s are 16. So here we'll subtract 16. So 4 plus 4 is 8 and we have a blank space here. Here we have 1 and we keep it down, so it's 164 here. Now we have a blank space here and we have a blank space here. Now 8 into an 8, a number multiplied by that number itself gives us 164. So what is the number which gives us 4 as a product as last number? What if we put 2 here? What is 82 into 2? It's 4, 8 2 is 16. So we got 164. So we put 2 here, 2 here and 2 here. So it's 164 and we got 0 as the result. Now 42 is the square root of 1764. Let's solve the next question. Which of the following numbers is a perfect square? So in this question, we have to find this perfect square. So when we are checking the squares of a number, we have 1 square equal to 1, 2 square equal to 4, 3 square equal to 9, 4 square is equal to 16, 5 square is equal to 25, 6 square is equal to 36, 7 square is equal to 49, 8 square is equal to 64, 9 square is equal to 81 and 10 square is equal to 100, right? So what is the pattern we could see in the squares of a number? We have 1 at the unit place, 4, 9, 6 in the units place, 5 in the unit place. Again it goes to 6, 9, 4, 1 in the unit place and then we have 0. So the only numbers are having 6, 9, 4, 1 and 0 in the units place. So we have 6, 9, 4, 0 and 1 in the units place for the squares of a number, right? So here 8 and 7 cannot be seen in the unit place of any of the perfect squares, right? So these and these option is already eliminated from this, right? Now we have two options. It's either 481 or 576. So let's find the root of 481. Let's see, is it divisible by 2? No. Is it divisible by 3? We have 8 plus 1 is 9 and 9 plus 4 is 13. So it's not divisible by 3. Now, is it divisible by 5? It's not. Is it divisible by 7? Let's see, 7, 6 sevens are 42, right? So 42, 48 minus 42 is like we'll get 6 and 61. It's not divisible by 7. Is it divisible by 9? We have 1 9s are 9, 4 9s are 36, 5 9s are 45 and we'll have 3 balance 31. Again it's not divisible by 5. So I think it's a prime number, right? Now we'll see about 576. Can we divide it by 2? Yes. 2 2s are 4, 1 7, 8 2s are 16, 1 6 and again 8 2s are 16. Again by 2 we'll get 144. Again divide by 2 we'll get 72. Again divide by 2 we'll get 3 2s are 6 and 6 2s are 12, 36. Again by 2 we'll get 1 8. Again by 2 we'll get 9. So now we can't divide it by 2 but we can divide it by 3, right? Now by 3 we'll get 3 and by 3 3 and 1, right? So we have 2, 2, 2 and 3. That is 3 times 2 multiplied by itself into 3, which is 8 into 3, which is equal to 24. 1 8s are 8, 2 8s are 16 and 3 8s are 24. right? So 576 is the perfect square in this number. Now let's move on to the next question. What is the value of root 64 plus root 49? So we have to find the value of root a plus root b. So this is not equal to root of a plus b. Let's see. 64 plus 49. 9 plus 4 is what? 13. 6 plus 4 is 10 and 11. What is root of 113? We don't have to find that. First, root of a here is equal to root of 64, which is 8, and root of b equal to root of 49, which is 7. So the answer simply is 8 plus 7, that is 15. Now moving on to the next question. The square of a number is 625. So what is the number? Basically, we just have to find the square root of 625. So which number is it divisible with? 5 plus 2 is 7. 7 plus 6 is 13. It's not divisible by 3. So what do we divide it by? 5, because 5 is the last number. So 1 5s are 5, 12, 2 5s are 10, 2 25, 5. So again 5, 2 5s are 10, 25, 5, 5 5s are 25, again 5, here we get 1. So we get 2 pairs of 5 here, which means 5 into 5, which gives us 25. So 25 is the answer of the question. Which of the following numbers is a perfect square? Again, we have the same kind of question and we'll check. So this one we can't say by looking at the unit place because we have 9, 6, 5 and 6. So 169, is it a perfect square? Let's see. What is the square of 13? 3 3s are 9, 3 1s are 3, 3 1s are 3, 1 1s are 1, 9, 6, 1. We got the answer here. It's actually very nice to remember the square of numbers at least till 15 so that you get questions like this and it's very easy to answer them. So let's move on to the next question. What is the square root of 0.04? So we have 0.04. Either you could do the prime factorization method where you could go like this is divisible by 2, so it becomes 0.02. Again, it's divisible by 2, so it's 0.01. Then it's divisible by what? What should we multiply to get 1? So 0.01 into something is equal to 1. What is the number? 100. So is it possible to do that? Yes, it is. So what should we do? We get 1, right? So this is the wrong way to do it. But we know that 2 is the number, but 0.04 means that 0.2. If we are squaring 0.2, what would we get? We get 0.2 into 0.2, which is 2 2s are 4, and we have 2 decimal places, so we jump on 1 and 2, 0.04. So if the square root of a number have 2 decimal places, the square of the number, so this is the square of the number. If the square have 2 decimal places, the number would have 1 decimal place or half of its decimal place. Now, moving on to the next question. Which of the following is a Pythagorean triplet? So what is the property of a Pythagorean triplet? So a Pythagorean triplet, a number square is equal to square of the other number plus square of the other two numbers, right? So let's see. Let's take the square of these three numbers. So 3 square is 9, 4 square is 16 and 5 square is 25. Let's see whether 9 plus 16 is equal to 25. Yes, we have 9 plus 16 is equal to 25 and 3, 4, 5 is the right answer. We have a triangle. This side would be 5, this would be 3 and this would be 4. Now this is a Pythagorean triplet. If we are checking about all the other scenarios, we have 25, we have 49 and we have 81. This is clearly not the sum of this one. Now option C would be 8 is 64, 100 and 144. So 64 plus 100 is not 144. So this is also a wrong answer. Now for the next one, we have 169, 14 square, we'll find it out. 14 square, we have 14 into 14. 4 4s are 16, 4 ones are 4 and 5, 4 ones are 4 and 1, we have 6, 9 and 1. So 196 for 14 and 15 square is 225. And this is also, the sum of both of this number is also not 225. Therefore 3, 4 and 5 is the right answer. Now let's move on to the next question. What is the value of x in the Pythagorean triplet 9, x and 15? This means that 9 square plus x square is equal to 15 square, right? So 9 square is 81 plus x square is equal to 15 square is 225. Now x square is equal to 225 minus 81. So we have 225 minus 81, we have 4 here, this is 12 and this is 1. So 8 plus 4 is equal to 12 and 1. So this is equal to 144 and x is equal to root of 144, which is equal to 12. So the answer for this question becomes 12. Now, moving on to the next question. What is the sum of the squares of the side of a right angle triangle with side lengths 5, 12 and 13? So, the question once again, what is the sum of the squares of the sides of a right angled triangle with side lengths 5, 12 and 13? So, we have a right angle triangle and this is 13, 12 and 5. So we need the sum of squares of the side. So 5 square plus 12 square plus 13 square, which is 25 plus 144 plus 169. So let's add this up. 169, 144 and 25. This is 9, 9 plus 9 is 18. 6 plus 4 is 10, 12 and 13. And this is 338. The option is not given here, but still this is the answer, 338. Let's check again for 5, 12 and 13 it is. And it's asking the sum of squares of the sides of triangle and the side lengths are given. So 5 square is 25 and 12 square is 144 and 13 square is 169. Just checking to make sure. 3 3s are 9, 3 1s are 3, 3 1s are 3 and 1 3s are 3. It's 169. So let's add it again. 5 4 9, 9 plus 9 is 18. 3 4 7, 7 plus 6 is 13 and 338. Yes, 338 is the right answer. So moving on. Which of the following is a perfect square? So this option is already eliminated. Now let's see what else do we got. 239. Is it divisible by 2? No. Is it divisible by 3? 9 plus 3 is 12. 12 plus 2 is 14 and it's not divisible by 3. So is it divisible by 4? 39? No. Is it divisible by 5? No. Is it divisible by 7? Let's see. So 7 3s are 21 and 29. It's not divisible by 7 either. So let's see with 289. So is it divisible by 2? No. 3? No. 5? No. 7? 7 3s are 21. 7 4s are 28. And 9 remains. No, it's not divisible by 7 either. What about 3? 11. So 311. It have 2, no. 3, no. 5, again no. So 6 doesn't matter. 7, 4 sevens are 28. 31, no, it again doesn't. So this question doesn't have a right answer here. So what do we do? Let's see what should we add with any of these numbers to make it a perfect square. So 239. So what is the nearest perfect square between this? Let's see. 239 and we'll just jump on to the next question. The square of a number is 144. What is the number? Square root of 144, we know that it's 12, but still let's go solve it. We have 2 times, which is 72. Again 2 times we have 36. Again 2 times we get 18. 2 times we get 9. 3 times we get 3 and 3 times we get 1. So we have 2 into 2 into 3. 2 into 2 into 3, this is 4 into 3, which is 12. 12 is the right answer. What is the square root of 0.09? Very easy question. 9's root is 3 and skip half of the decimal place, so it becomes 0.3. Next question, which of the following is the Pythagorean triplet? So 6 square, 36 plus 8 square, 64. So 36 plus 64 gives us 6 plus 3, 9 plus 1, 10. 100, which is the root of 10. So here we go, we got the right answer. Now, which of the following is not a property of square roots? The square root of a perfect square is a whole number. This is the right one. The square root of 0 is 0. The square root of negative number is undefined. The square root of a non-perfect square is an irrational number. This is also true. So, the square root of a negative number is not undefined. The square root of a negative number is represented by a digit called I. We represented I as root of -1. So, this is the wrong answer. So, this is the right option. Now, what is the square root of 1764 using the prime factorization method? So, we have to use the prime factorization method to find the square root of 1764. It's going to be quite long, so let's do it. We could divide it by 2, we'll get 8 2s are 16, 8 2s are 16 and 2. Again by 2, we'll get 4, 4 and 1. Now, is it divisible by 3? Yes, because 8 plus 1 is equal to 9. So, 3 times we'll get 1 3s are 3, 1 4, we have 4 3s are 12 and 2 1, we have 7 3s are 21, right? Now, 7 plus 4 is 11 and 11 plus 1 is 12, it's again divisible by 3. We have 4 3s are 12 and 27, we have 9 3s are 27. Now, 7 into 7 is 49, so 49 divided by 7 gives us 7, and again we'll divide it by 7 and we'll reach 1. So, we have the answer to be 2 into 3 into 7. So, 2 into 3 is 6 and 6 into 7 is 42. So, the answer for this question is 42. Now, what is the square root of 144 by the long division method? Now, we know the square root of 144 is 12, but here we have to use the long division method to say that what is the square of 144. So, let's see. 144, by long division method, we are pairing 44 and 1. So, what is the nearest square? 1, 1. So, we subtract 1 from here and we add 1 from here, adding and subtracting. So, it becomes 2 and something. So, 1 minus 1 is 0. We have 44 down here. Now, we know that 2 into some number multiplied by the same number gives us 44, and it's of course 2. So, we'll put here 2, here also 2, 44. So, by long division method, we got 12 as the answer. Now, The formula for finding the digits in the square root of a perfect square is based on, so the question again, the formula of finding the digits in the square root of a perfect square is based on the remainder theorem, the binomial theorem, the square cube rule, and the digit sum rule. It's of course the remainder theorem. So what is the square root of 3249? So 3249 is comparatively a longer number, so or a larger number, so we take it using a long division method. So let's read. We have 49 and 32. Which is the closest square which is closer to 32 is equal to 32 or less than 32? So we have 4 square is 16, 5 square is 25 and 6 square is 36. So let's take 5. So 5 square is 25. So we add 5 here, we subtract 25 from here. So what is 32 minus 25? This becomes 12 and becomes 2. So this is 7. So 7, 10, there's a blank. This number comes down and here's a blank. So we should get 10 into some number into the same number should give 749. What if we put 7 here? So 7 7 sub 49, 4 balance, 4 comes here, 7 1s is 7. Yeah, sums up. So 7, 7 and 7 gives us 749, remainder gets 0 and we get the answer as 57. So moving on to the next slide. The square root of the products of two numbers is equal to, so the square root of the product of two numbers is equal to the sum of the square roots. Is it root a square plus b square? No, it's not. The product of this square roots, is it root a into root b? Yes. The difference of the square roots and the quotients of the square roots. Both of these are wrong answers. So this is the right answer. Now, what is the square root of 9.61? So let's see what is 9.61 by long division method. 61 and we have 9. So we have 3 here, 3 here, 3 3s are 9. So we add 3 here, subtract this, so we get 6 and some number 0, and here we add the point 61. We have a number here, 6 something into something gives us 61. So how about 61 into 1? So we put here 61, 1, 1, we get 61, 0. So the answer is 3.1. Next question, what is the square root of 3 by 4? So this is in the form root of a by b. The question is root of 3 by 4, which could be written as root a by root b, which is root 3 by root 4, which is root 3 by 2. Got the answer here. Now, the square root of 4356. Again, we are doing the long division method here. It's 4356, long division. Okay, 56 is a pair, 43 is another pair. The square which is very close to 43 is 6 square, which is 36. We put 6 here, we add 6, we subtract 36, and here we get 12, and 43 minus 36, it's 13 and 3, so this is 7. So we got 756 here, and we have a blank spot here and a blank spot here and a blank spot here. So 120 something into something, it gives us 756. What should we do here? So either what number should we multiply together to get 6 here? What about 4? 124 into 4, 4 4 is 16, 1 4 2 is 6, 7 477. No, it's not 4 then. So what's the next number we could put here? 4 5, no. 6, no. 7, no. So which would be the closest number we could get here? Let's see that. 124, 5, 6. Let's see 126 into 6. 6 6 is 36, 6 2 is 12, 13 14 15, 6 1 is 6 and 7. It's 756. Yes, so we get 66 here. 756 and the remainder goes as 0 and it's 66. Now, what is the square root of 0.25? So 0.25 have a square root of 0.5 because 25's root is 5 and we reduce one decimal point and we get 0.5. The square root of 441. So which method should we do? Let's do prime factorization. We've been doing long division a lot. So yeah, prime factorization it is. 8 plus 1 9, so it goes by 3. 1 3 is a 3, 1 4, 4 3 is a 12 and 21, 7 3 is a 21. Again 3, 4 3 is a 12, 27, 9, 7, 7 and 1. So it's 7 into 3, that's 21. Next, what is the square root of 169 by long division method? Let's see. 169. Long division, 69 a pair and 1 a pair. It should be 0, 1. It's okay. Now, 1, 1, 1 here. We'll add 1, subtract 1. We'll get 2 here with a blank. Now, it's 69 coming down. Now, 2 something into something gives us 69. What is 23 into 3? 3 3 is a 9, 6. So the number here is 3. So 3, 3 and 3 gives us 69, 0. Answer is 13. Now, the square root of 49 by 64. Again, it's a very simple question. Root of 49 by 64 is equal to root of 49 divided by root of 64, which gives us 7 by 8. So this is the right answer. Now, what is the square root of 0.01? So root of 1 is 1 and 0.1 is the square root. Last question. The square root of 625 is. So again, we'll do it by prime factorization here. 625. So we do it with 5. So 1 5s are 5, 1 2 2 5s are 10, 2 5 5. So 5 again, 2 5s are 10, 25, 5, 5 again, 5, 5 and 1. So we have 5 into 5, that's 25 as our answers here. So these are the few important questions